So quadratics unit, we're talking about day 2. The warm-up questions per se that we're going to look at is a good introduction into the kind of methods that you're going to use to solve for your quadratic equation for your performance task. Okay, so here we go. So the first 30 minutes of class today, we're going to go over these techniques of how you can get the equation of a parabola. But they are very helpful for you as an individual in group, because at the end of class today for an hour, you're going to be with your groups. This is why I asked you to bring a ball in today. So you could have a tennis ball, you could have a soccer ball, whatever the ball is, you're going to show this parabolic pathway, right? This path that the ball is traveling. And what we do here in this first 30 minutes is going to be very, very helpful for that, okay? We'll get to that whenever we get there. But there's some great examples here, so let's go ahead and begin. So my standard form right here for a quadratic, and this again is going to be in your notes. Okay, so like I was saying, we are going to take the standard form for a quadratic, otherwise this kind of graph that we're looking at in Unit 2. Okay, just real quick, y is equal to x squared has this parabolic shape. A couple of features about this is that the default parent function starts at 0, 0 as far as the vertex is concerned. The next one is over 1 up 1, and then over 2 up 4. Okay, and the reason of that is, and then left 1 up 1, and then left 2 up 4. Real quick, some basic things about this. Y is x squared. So if I have if I have 0, 0 squared is 0. If I have 1, 1 squared is 1. But if I have 2, 2 squared would be 4. And just like going to the left, negative 2 squared is a positive 4 because I'm thinking about parentheses. And a negative 1 squared is a positive 1 because I'm thinking about parentheses. Okay? So that's the basic form for a quadratic. So this is a very important point, and these two pivot points that surround the vertex are very important. Because on the standard, it's up 1 over 1. Okay, we've talked about with absolute value, if there was a vertical stretch here, let's say it said 3x squared, this would be a vertical stretch by 3, means it would be up 3 over 1. Okay, if there was a 5 there, it would be up 5 over 1 for this first point, and it would definitely be stretched out. Something that looks like that. Okay, just getting your brain going as far as the features about the quadratic. Any questions before we go ahead and start? Okay, so the standard form we have is ax squared plus bx plus c. Okay, and what we're going to do is we're going to try to write a system of equations. So in your performance task, this is one of the ways that you can do your performance task, is the systems of equations. It's very, very easy to do in a lot of respects, and we need to definitely know how to do both systems of equations and regression. Let's go ahead and do this system. So in this equation, if I use 0, 0, what I'm doing, and notice the color coordinating, I'm going to put 0 for all of those x values. Okay? And this 0, I'm going to put as the y value, otherwise the output. So this is an xy, and all I've done is substituted into the standard form. Okay? You notice these two terms zero out. Okay, anything multiplied by 0 zeroes out. And all you're left with is a c on the right side and a 0 on the left. So already you found c. Because your goal when you're finding a system of equations, especially with 3 variables, is you're trying to find out what is A, what is B, and what is C. Well, we know what C is right now, just from one point. And we strategically did this by putting in this 0 for x, because then the A and the B term zeroed out. Okay? Okay, so let's keep going. If I use, right here, these are just points that I'm telling you to use. You will come up with these points on your own when you're doing your performance task, and I'll show you how you can do that when we get to that point. So negative 1 again, is going to be placed where all the x's normally lie. Okay, so let's go ahead and put this x value right here and right here, again, where x normally lies in the standard form. So a big thing that people get wrong is that they think this is the same as that. Okay, by now you should know from the algebra that we've done in class that in this one, PEMDAS comes first. So what it's saying is do the 1 squared first and then multiply it by a negative, which would give you a negative 1. But this one, guys, when you put in points like this, always, 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 so that you don't miss these, use these parentheses right here, okay? Because negative 1 squared is the same as negative 1 times negative 1. And a negative times a negative is a positive, so this would positive out. That's why those two are definitely different. Okay? All right, so putting in this negative 1, we square, we get a positive a. Putting in a negative 1 right here, we don't square it, so we're going to get a negative b. And we get this equation right here that is a minus b plus c is equal to negative 2. Okay? How did I go from here to that equation right there? Anyone, just say it out loud.
The c you already know is 0.
Yep, c is 0. So if c is 0, we don't even have to write c there. You with me? So for the next one, when we use 1 and 6, we're going to put 1 in for x. We're going to put 6 in for y. We get a plus b plus c. And again, we know c is 0. So if c is 0, it's like you don't even have to write it in order to get your system of equations that you have right here. Okay? Guys, let's see if you remember it by name. If you're doing this by hand, what was the one that I said is the fastest and most effective method? Elimination. Yeah, and right here it's already set up for us because I have a positive and a negative b term that when I add these two together, b's cancel out to what number? 0, right? The b's 0 out, and I'm left with what? 2a is equal to 4. So a is what? 2. So now we found a. So if c is 0 and a is 2, how do I find b? Just plug it into any one of these equations, right? So if I plug in, doesn't matter which one we use, you tell me which one do y'all want, the first or the second one? Second one? So let's put a is 2 right here. So 2 plus b is 6. So anyone, what's b? 4. So I got 2, 4, whoops, and 0 as far as my answers, so that my original equation, which used to be ax squared plus bx plus c, is now going to be y is equal to 2x squared plus 4x, and that's it. I don't have to put plus 0. Any questions from that? So how many points were necessary to do this? 3. So and write it down in your notes if you need to. If you do it by a system of equations, you need 3 points. This is why in your performance task we ask for 3 points. Why do we need 3 points?
Because you need to make the 2 equations and you prove the
So we're proving the y-intercept, and the big reason why we need 3 points is because we have 3 variables. We have a, b, and c. So if I have 3 points, 3 sets, it's like I'm having 3 equations that I can solve for this 3-variable system. You with me? Okay. So let's move on. So that was a system of equations, and this is just finishing it off. And this is still finishing it off. Alright, so now let's look at an example. So this is really, really close to what you're going to do today. And you're going to record this. Okay, so I really want you asking questions right now because I'm not going to answer questions when you guys go to do your 1 hour together in groups. I want you to take everything that was discussed and what we talked about during this first 30 minutes and collaborate and come up with what are you going to do for that hour when you record. Yes?
what was that afterwards of talking about?
Let's get to that Not just yet. Okay. So using a quadratic model, basketball follows a parabolic path through the points shown. If the center of the hoop is at 1210, so let's say this center right here, the point is 1210. Its x value is 12. And those of you who don't know, the goal is 10 feet high. Okay? Will the ball pass through the hoop? Find a quadratic model, substitute the x and y values into the standard form of the quadratic. The result is a system of 3 linear equations. So this is really very similar to what we just did. The only difference is now we're going to just do it with a word problem. Okay? Okay, here we go. So notice the technique, the strategy. You're putting 2 in for x, which is why you have this here and here. And you're going to put 10 in for y, because this is a point called xy that is on the parabola. Okay? We get 4a, 2b plus c, that's my first equation, is equal to 10. We can get a different point. Why do you think we use 10, 12? Why would we use 10, 12? Like, where does 10, 12 even come from? Is it the same as this point right here?
No.
No, it's not the same. You with me? But we're saying 10, 12 would be about right, here's 10, and 12 is a little higher. So 10, 12 is about right here. It could possibly be the vertex. It could possibly be the vertex. Here's the thing with a parabola. It's very symmetrical. You with me? So if I were to draw, let's do one more point. 4, 12. 1, 2, 3, 4, and then 12. It's very symmetrical to where if the ball's released here, and it has that symmetry about it, most likely the vertex lies somewhere there. You see what I'm saying? So looking at this, I can develop like a center point somewhere by looking at those common heights right here. So if their height is 12 at both 4 and 10, what did we do recently in the other unit that we could find that halfway point like that? How do you find the halfway point between two values? Add them in, divide by 2. So the halfway point would be just add those two things and divide by 2. So it occurs at 7. So the vertex, we found by this symmetry and dividing it by 2, we see that x is equal to 7 would be the vertex somewhere in the middle. You with me? So that's why a lot of times whenever you're shooting a ball like this, or if you're shooting a rifle, or let's do archery, whatever it is, you always kind of aim for an apex before that target that you're shooting at. You don't necessarily aim for the target because you would be possibly a little too high or a little too low. Okay? So plugging in these points, we get this system right here. We have a 3 by 4 augmented matrix, which we could put in the calculator as row reduced echelon form of, and we've done this before, 4, 2, 1, 10, 100, 10, 1, 12, and 16, 4, 1, 12. Remember, it will spit out your 1, 0, 0, 0, 1, 0, 0, 0, 1, and it will spit out your answers as far as what is A, what is B, and what is C. Any questions on this? Another way that you can solve this, actually, let's go ahead and do that together. So since we're going to be going to the calculator here in just a bit. That last hour is pretty hefty as far as what you're needing to do. So I want to give you all those tools right now of how you can find this. Let me start. Okay, so with me, what I did is go ahead and start a new document, no to unsaved changes, and press 1 to get a graph going. Good practice, I will do Control plus, just add a graph by pressing 2, and then Control F. That's a good default. I keep doing that over and over and over again as I open up a new document. What we're going to do is we're going to solve this system by doing the augmented matrix. I know it's been a while, but this is a big reason why we had systems of equations. Yes, I did record videos for that test review mentioning that they would be on the test because we got to get you back into that frame of mind for what we're doing in this unit. So RREF parentheses, and then press this key right next to 9. We're going to look for the 3 by 3 matrix, and we're going to change one of these numbers to something else. Which one are we going to change? Number of columns. So we're going to change the columns to what? 4. So now we're just going to put in our matrix that we built together way down here, and we're going to put them in right here in this 3 by 4 augmented matrix. And the reason why it's a 3 by 4 is because it's 3 rows by 4 columns. Remember, this is the A, B, and C column. They have to be organized that way. Here's your equals, and then there's your number. When it spits out the matrix, I'll show you where A, B, and C belong. Here we go. 4, 21. Wait, not 21. 4, 2, 1, and 10. Please correct me if I make a mistake. 100, 10, 1, and 12. Then we have 16, 4, 1, and 12. And you see my answers here. So my answers, because A was first, B was second, and C was third, my answers will spit out as the following. They will spit out as A, B, and C. Whoops. So we'll say A is equal to -1/8, B is 7/4, and C is 7. Oops, C is 7. Any questions right now? Okay, so let's go back to the notes. And let me go ahead and scroll up so that you can see what they have as far as an answer is concerned. So they have this right here. Let's see if they have the same terms. So they got a -1/8. Well, we got a -1/8, and that's the same as -1/8, but in decimal form. Okay. This 7/4, otherwise 1 3/4, is this one right here, this 1.75. And then C is equal to 7. There it is. So this is your equation of this, and we solved it with a calculator now. You with me? So what made it that we solved this with a calculator and compared to the other one that we didn't solve with the calculator is that the other one we had 0, 0. This one we don't have 0, 0. We had 3 distinct points. You with me? Questions? So real quick, another way that you could have solved this is from those 3 equations that we built together, we did row reduced echelon form right here in the box. You could straight up just put that into your calculator this other way, okay? Just to review you, let's go to the calculator. Menu 1.4, okay to clear storage. Menu 1.5 to get a nice clean sheet. And here we go. We are going to put, instead of the augmented matrix, we're going to go ahead and do it the easier one, the much, much easier one, okay? So menu, 3 for algebra, 7 for solve system, and 1. How many equations do I have? 3. And it will default and it'll make it into XYZ immediately for you, okay? Now, I can, if I want, come over here and I'm going to change this to A, change this to B, and change this to C, just so I don't have to remember which one's which. And then I'm going to go over here, and this equation that I had from before, this 4A plus 2B plus C, all of this right here, so 4A plus 2B plus C is equal to 10. This 100a plus 10b plus c is equal to 12. And this 16a plus 4b plus c is equal to 12. I'm going to put that into the calculator like this. So 4a plus 2b plus c is equal to 10, 100. And this one you don't have to put in columns. You don't have to put all the a's together, all the b's together. This one you can type in just as you see it. It will do all that work for you. And then plus c is equal to 12. And then last but not least, 16a plus, what was that? 4b plus c is equal to 12. And you get the same numbers that we got with the augmented matrix. Any questions? Okay, and guys, whenever I press this again, enter to copy, if I do Control Enter, controls that blue button, it will access all of these little blue things up top. And if I press Control Enter, this approximation means a decimal answer. So if I press Control Enter, you'll see the answer spit out. Oops, it should. As decimals. Okay? Questions? Okay, so let's go back to our... So here's the thing. This is what you're going to concentrate on today. As you record the ball and path, and you're doing this as a group, I suggest that you do it with a backdrop, some kind of backdrop of like bricks. Because if you have bricks that are like in the backdrop, what these bricks can kind of serve as, whatever, we have plenty of bricks in the hallways, is that they can serve as, if I go over one and up one, this could be 1, 1. But if I go 2 bricks over and 2 bricks up, that point could be 2, 2. So it's like a reference grid that's kind of like in the background that'll show what points are you going to use. How many points do we want to get? 3. And these are the points that you're going to use. You can use whenever you launch the ball. You can use while it's in the air. I would use while it's in the air. Most of them are better accuracy that way. But you're coming up with 3 different spots that it's in the air. You with me? Any questions on that? Okay. So, one last thing. If I wanted to know that this was in fact going to make it and hit this, if I wanted to make sure that it was going to go in the goal, meaning that it would hit this position at x is equal to 12. All I can do is this quadratic equation that I got is I can plug it into the calculator and see, does it spit 10 out when I put 12 in here? You with me? So real quick, just so you can see it, I want you to get used to this calculator very, very good. Let me show you real quick. On that equation that we just built, that y equals equation, what I'm going to do is I'm going to save it right now. Here we go. So I'm going to put control divide -1/8, and if you do this, I promise it will be much faster comparatively to those who don't learn this when you take your test and quiz. So we have 7/4 x, make sure you write an x there, and then put +7. This is my f of x, okay? So if I control, press it with me, the blue button, var, it accesses this store feature right there. And I'm storing it as f of x. So now I can say, let's see if it's going to make this shot. Let's see if it will hit right at a height of 10 when I put in what x value? 12. So here we go. If I put f of 12, bam, it hits 10. This will tell me how high will this be at 12. You do control store. So again, that arrow, if I press the blue button and the vars, it will do this arrow right there, okay? But you always have to do, real quick, you know how you have like f of x is equal to x squared plus 1? the way you store it is that you type it like this, and then you store it as f of x. Okay? So right here, if I wanted to see how high would this ball be, and I can predict the future basically off this model at 6 feet away from where I'm shooting. Okay, you see what I'm saying? I could say f of 6. How about 7 feet? F of 7. And then you can do control answer to get them in nice decimal forms. Y'all with me? Do y'all see how I'm doing this? Okay. Yes?
When we're doing it like the project, do you want the decimal form?
I would prefer it in decimal form and at least 3 decimals. That's a really good question. As you work through the problems, as you are working through the problem, you should always try to use as many decimals as you want. A minimum of 6 decimal places. Okay? But as you give me the answer, when you're ready to give me the answer for each individual piece, I want it in 3 decimal places. Go with me? Alright, so a couple more things that I'm going to show you to build this calculating knowledge, and yes, I will post this online. Let's go to our table. So over here, what we're going to do is, from this screen, I'm going to now put control, actually from the second screen, I'm going to put control to the right to go to 1.2. And now I'm about to put this equation in that I got. Okay? I can retype it all out as far as a negative 1/8 x squared plus 7/4 x plus 7. Or what I could have done is just typed in what I saved from the previous screen, which is just f of x. Same thing. So let me show you on that tab. I'll say f of x, because that's what I stored it as on the other screen. And of course, you'll see it lie right on top of it. Okay? Because it's the same exact graph. Something that you're going to need to get accustomed to is, let's look at this graph as far as a parabola is concerned. So menu, zoom, so 4. And guys, you're going to use this a lot for the rest of the year. Menu, zoom, fit. So A, you can either scroll down or press A. It will fit at least a good default picture of where most of your information lies. That is needed and important. You with me? And then from here, you can zoom in and zoom out as far as where the vertex is at. You know what I'm saying? Like, follow me. Here we go. Menu, zoom. You can zoom out by pressing 4. And let's put the center over here somewhere near the vertex or axis of symmetry. And it'll zoom out just a little bit. And it'll give you a good picture as far as the path of this ball. Go with me? Any questions? So right now, just a couple more things. If I wanted to see these values that I had stored, okay, and I was showing you what's f of 6, what's f of 7, what's f of 10, but I wanted to see it on a table, just for knowledge, Control T for a table, but you have to do it from a graph. You can actually put in all these values. Let me show you what that looks like. Okay, here we go. So let me clean this up just a little bit, because I don't want you getting all confused on this.
How did you get it to look like that?
Control T. So soft mouse will come over here, and I can grab any one of these equations. Let me take off the table real quick. So Control T so that you can get practice with that. Control T will make the table go away. If I soft mouse on this equation, and I move it over here to the bottom left, and then I'm going to press Tab, and since it's a duplicate, I'm just going to delete the second one that I grabbed. I just showed you that so you could see the storage feature. Now Control T to bring back the table. And now what I can do is I can put in certain values depending on what I want to give it. So from here, menu, table, edit table settings, 5. Okay, and you can watch this video later. If I change my independent variable to ask, it's that third one down, and then just soft mouse to OK or press enter. Now, like what I did before, I can put 12 and I'll get 10. I can put 6, I'll get 13. I can put 7, I'll get 13.125 because it's stored in the graph with the table. Okay, and I put my independent variable set to ask. Okay, any questions from all of this? Because there's one more method that I have to show you as far as to solve for this. And you can use either one of them, you can use a couple, we must learn them all though, okay? Whatever one you're most comfortable with, you can put in your performance task. The last way that we could solve this equation that we got is the following. So follow me, and if you do get behind, please just watch the video later and just sit there and watch. I'm going to do from here, Control T to move the table out of the way. And I'm going to add a page. Here we go. Control Dock, this button at the very top right. I'm going to add a spreadsheet. This is the regression way that we're going to do this, okay? So I'm going to add a spreadsheet by pressing 4. There were 3 points that we got from this picture, okay? Those 3 points I'm actually going to put in right now. I believe the first one was 210, is that correct? Okay, so 2, and then we're going to have the y value of 10. The second one was 10, 12. So 10, 12, and then the last one was 4, 12. We've done this before. It's been a while, but this we did like the very first unit when we did linear regression, but now we're doing it as a quadratic regression. So over here, all these are x's. So I'm going to put x at the very top. All of this column B are y values. Does anyone remember what we do from here? Like to get the actual graph? Do y'all remember? So, yeah, so Control Dock, and it's going to add a data and statistics. So we're going to do 5. Nice on the memory. Now we're going to change this variable to what? X, nice. We're going to change this variable over here to what? Y. And it will graph out, and you can see that it looks like a quadratic already. Okay? And from here we're going to do menu, what? 4. Menu, analyze, 6, the regression, and guess which one we're doing? Quadratic. So we're going to press 4. And look, it got exactly the same equation, much, much faster for us. You've now learned it as systems of equation. You've learned it by an actual setting up a system with an augmented matrix. You've learned it by a graph. You've also now learned it from a regression.
So we can choose whichever one.
You can choose whichever one you want. Okay? Any questions? Alright, so to finish up this video, what we're going to do is we're going to go to, real quick, we're going to go to this checkpoint 1, and I'm going to quickly review a couple things with you. Oh, FYI, this 5.3 Max XL right here, the homework, I will assign tonight, okay? And that one will be due for you on Wednesday. Okay, it's always by midnight the next class. Okay.
Thursday.
Oh, my bad. Thursday, yes. So today's Tuesday, yeah. Thursday for you guys and Friday for B Day. Alright, so checkpoint 1. Let's go ahead and review checkpoint 1. So again, you're going to, for the rest of the period here in just a bit, you're going to record a naturally occurring parabola. Okay, so this naturally occurring parabola, this is why we brought tennis balls, soccer balls, whatever in motion. You can use a water fountain if you didn't bring anything. Water fountain's going to be a little bit weird though because you don't have those bricks in the background, but no worries. I'll show you something that you can use here in just a bit. Use this recorder to find 3 points, just like we did today. 3 points on the parabolic path. Next you will find the equation of the parabola using several methods. Okay, using several methods, not choosing from several methods. Both with and without a calculator. You will do it with the system of equations, with either algebra or matrices, and then you will do matrices with the calculator, and then the third and final way that you will find it, so it's all 3, okay, is the regression. Okay? Any questions from all of this? Yes?
So how would you show your work for the ones on the calculator? Is there a way to take a screenshot?
Show your work the ones in the calculator, yeah, whatever you do on the calculator, I would just write and type out as far as what is it that you actually enter the calculator. If you want to get fancy like that and take a screenshot, I'm okay with that too. Just remember to read the rubric because there are certain pieces that must be handwritten and make sure that you have those completed correctly. Okay. Here we go. So let's go to part 1. 15 points due on these following dates. Submit digitally 1 per group. Each group submits 3 digital photos from the video. And guys, if you didn't know that, you can record video and snap. You know that already. Hopefully that you can just snap pictures as the video is going. You can do screenshots, or you can, there's a button at the bottom that you can just press as the video is recording. It's that white button that will take pictures as the video is recording, if you didn't already know that. Or you could do one single showing all 3 points. So if you do one single photo showing all 3 points, or you can do 3 digital photos showing 3 different positions. You with me? Consider recording your video in front of a brick wall to use as a coordinate grid. Or here's the thing right here. So pixlr.com is something that you can use to help you as far as getting a good grid going on. Each photo should show the ball or a point on the path labeled with integral coordinates. Look at this at the very end. Includes a separate professional looking graph. Consider using Desmos. So you guys are going to be busy for the rest of the period for sure. And you can get this done today if you really bust it out. With these 3 points clearly marked and labeled on the coordinate system. Guys, when I want this Desmos, I do not want these points on top of your photos. Okay, so don't try to do a Desmos graph by putting the picture on there. I just want a Desmos graph. Okay, the photos is something different. Do we understand? Are there any questions? Yes?
What's the app that you talked about the other day?
Let me look for it as you guys are working, okay? I would prefer that you do use the bricks, only because the app, it can get a little bit weird and a little bit too off of what we're trying to do. You know what I mean? The app does too much for you is what I'm saying. I'd rather you do the math to find this equation. Okay? Alright guys, for the rest of the period, you are working with your groups. You may go out into the hallway. Please do not be loud. Do not disrupt other classrooms that are going on. You can do it in here. You can do wherever you want. In the hallway over there in front of the auditorium. You have 45 minutes to go ahead and finish this together.